All right, today we are diving deep into something that's quietly changing just about everything: computer vision. Basically, we're talking about teaching machines how to see.
So let's just jump right in with a question that might feel a little personal. Can a camera, just a camera, decide if you get a ticket? And the answer is a big yes. In India, which has more two-wheelers than anywhere else on Earth, this is already happening. There's a computer vision system that's actively identifying motorcycle riders who aren't wearing helmets. It reads their license plates, and bam, it issues a fine. This isn't science fiction, folks. This is happening right now.
And that real-world example really sets the stage for our first section. Seeing is believing. You're probably going to be surprised by just how much this tech is already woven into the fabric of our lives.
Okay, so let's zoom out a bit for section 2, the world through AI. Because what's happening is nothing short of a revolution, and it's happening right in front of us.
Let's start with a big one, maybe the one you first think of: autonomous vehicles. Yeah, self-driving cars are one of the most incredible and, frankly, complex examples of this technology in action.
I mean, it's pretty mind-blowing when you think about everything these cars are seeing every single second. They are constantly identifying pedestrians, keeping an eye on other cars, literally reading traffic signs, and perfectly tracking lane markings, all to make split-second driving decisions. You've got companies like Tesla and Waymo pushing the envelope here, all with the goal of making our roads safer and, well, a whole lot more efficient. But look, this tech isn't just on our roads. It's totally changing how we shop, whether you're clicking Add to Cart at home or walking down an aisle. Let's talk retail and e-commerce. Just think about the last time you were shopping online. You see that little "you might also like" section? A lot of the time, that's computer vision recognizing the product you're looking at and suggesting others. And in actual physical stores, places like Walmart are using it to track what's on the shelves, get alerts when things are running low, and even analyze how we move through the store to make the layout better.
Okay, so from the storefront, let's go behind the scenes to the factory floor and see what computer vision is doing for manufacturing.
In manufacturing, you can think of computer vision as like a quality inspector with superpowers. Seriously, it can spot tiny imperfections that are completely invisible to the human eye, automating a job that's usually tedious and prone to mistakes. But the real magic is the feedback loop. The system sees a flaw, and it can instantly tell the machinery to adjust itself or pull a faulty product off the line. That means less waste and better products for all of us.
And now let's talk about what is arguably the most life-changing application for this technology: medical image analysis.
The impact here is just wow. It's truly transformative. AI is basically becoming a doctor's most trusted partner, helping to analyze medical scans and spot diseases like cancer with astonishing accuracy. It can highlight a potential tumor on an MRI, find a hairline fracture in an X-ray, and even help map out a treatment plan. And let's be super clear, this is not about replacing doctors. It's about empowering them. It handles the more routine parts of the job so our amazing medical professionals can focus on what humans do best: complex problem solving and compassionate patient care. Okay, so we've seen all the incredible things this tech can do, which brings us to section 3, more than meets the eye. Because it turns out, teaching a machine to see is way harder than you might think. Yeah, so far it probably sounds like a superpower, right? But like any good superpower, it comes with some serious challenges. What's completely effortless for us, just opening our eyes and understanding what we're looking at, is for a machine an incredibly difficult task. Let's break down why. So the first giant hurdle is just how messy the real world is. It's chaotic. An AI is trained on data, but reality isn't a neat and tidy data set. We've got constantly changing light, different angles, things getting in the way of other things. This lack of consistency is a massive problem for an AI that's just trying to find a pattern.
Next up is something called robustness to noise. You see, real-world images from cameras are never perfect. They can be a little blurry or have weird glitches from the camera sensor. All of this is what we call visual noise. The system has to be smart enough to see past all that distortion and focus on what actually matters.
And finally, we have the huge challenge of generalization. It's one thing to train a model with a million pictures of cars on a perfect sunny day. But a truly smart system has to take that learning and apply it to completely new situations it's never seen before, like a foggy night, or a blizzard, or a super crowded street, all without needing to be retrained from scratch. Now, these technical problems are massive, for sure. But honestly, they open the door to an even more important conversation. Welcome to Section 4, The Moral of the Machine, where we have to talk about the human equation.
It's easy to think that worrying about AI ethics is a new thing, but it's really not. Get this. Way back in 1972, a very early AI called the London Hospital Predictor was designed to predict if coma patients would survive. And even back then, it raised serious alarms. Its creators actually warned doctors not to rely on its judgment alone. Now, you fast forward to today. In our hyper-connected world, and the stakes for getting things like fairness and privacy right, well, they're exponentially higher.
And to really get into this, we need to be clear on a couple of key ideas. First is bias. That's just an inclination for or against something, and it can sneak into an AI system through the data we feed it, or even in how we design it. Now, fairness is the goal. We want a model that acts equitably without unfair discrimination. The really tough part? Fairness isn't just a math problem you can solve. It's a deeply human idea, and what we consider fair can be completely different depending on the situation.
So what does all this mean for the people building these systems? It means they are grappling with some of the biggest questions of our time. How do we protect our privacy when there are cameras everywhere? How do we make sure these systems don't just make existing social inequalities even worse? And when an AI makes a mistake, who's responsible? These are not easy questions with simple answers, which is why things like transparency and always having a human in the loop are so absolutely critical. And all of this, the potential, the challenges, the ethical minefield, it all leads us to our final and maybe most important section. And it's a question not just for developers, but for all of us. What do we want to see? This technology, computer vision, is moving forward at a pace that's just breathtaking. It's learning to see and interpret our world in ways we're just beginning to wrap our heads around. But the biggest challenge isn't a technical one. It's not about teaching a machine to recognize one more object. The real question, the one we're all left with, is this. As we teach machines to see, what values are we going to teach them to see with?